Hi guys. Okay, so get your algebra notebooks out, please. Hopefully this computer doesn't get too laggy here. Catch up. Okay, so we're going to be doing two-step equations today. Two-step equations. All right, and just for reference, we are going to go ahead and write down the golden rule of equations. If you watched my last video lesson, hopefully you remember the golden rule. What's the rule that you always have to follow no matter how difficult or simple an equation is? You have to keep the equation balanced. Keep the equation balanced. So if you need more further clarification, you could go back and watch the other video, but really what this means is whatever you do to one side, you have to do the other. So if you want, you can just draw a little, balance, a little teeter-totter, right? Okay. And then we also had an overall objective. So when you're solving any sort of equation, what are you trying to get to at the end? What's the purpose? What's the point? What's the goal? I'm going to call it objective. The objective is to figure out what x equals, right? Or w, or whatever variable you have. So really our objective is to isolate the variable. Okay, and isolating a variable, what does that really mean? Well, you're getting the variable by itself. That's what isolate means, right? So we get the variable by itself. Well, how do you do it? You use inverse operations. Okay, so if x is subtracting by 10, I would add 10. We use inverse operations in order to cancel things out. We keep on getting rid of things that are next to our x so that we can isolate x. Okay, so those are the two main things when we're doing equations. We've got to always follow that rule, and then this is the whole point, okay? But let's go ahead and just see an example of a two-step equation, just so we can start talking about it. So let's do 2x, write this maybe kind of big, 2x minus 5 equals 13. Now I'm hoping that some of you remember this from last year, okay? And you're like, oh, I know what to get rid of right away, okay? And that's good. Hopefully you have that intuition. But if not, I want to talk about like what we're supposed to do, okay? So I still would like you to separate your sides. This seems to keep kids organized in their work and remembering that whatever I do over on the left, I have to also do on the right, okay? Or vice versa. Here's my variable, x. So I go to the side with my variable on it, and I notice, oh, it doesn't have just one number hanging out with it. It's got two, which is why there's two things I have to do in order to get rid of it. It's a two-step equation. I have to get rid of the 2 and the 5. But I think I know how. I would use inverse operations. That's how. But which one has to go first? Do you think it matters? Sometimes in mathematics it might not matter so much, but guess what? This matters. It matters which one goes first. So some of you might be going, oh, well, it's probably the 2 because the x is multiplying by the 2. I mean, that's correct. X is multiplying by the 2 first, and then it's subtracting 5. So it's tempting to get rid of that 2 first, but that would actually be incorrect, okay? So this x is following order of operations. It is first timesing by 2, and then it's subtracting 5. But when we're solving for a variable, when we're solving for something that's unknown, we actually have to kind of sneak up on it. Okay, we have to use reverse order of operations. So since the last thing that it's doing is subtracting 5, that's actually the first thing I get rid of. Okay, so you're good if you're thinking about PEMDAS. I mean, thank you. Okay, but when you're solving for an unknown amount, you actually use reverse order of operations, or PEMDAS. Okay, so maybe make that stand out in your notes. Okay, so we kind of do reverse order of operations. So let's go ahead and make some steps just so it's like super clear in our notes. What this means is step one would be to get rid of this 5, but we're going to go general. Remember, there's some vocab for these words. There's a vocabulary word for the number attached to a variable, and then there's a vocab word where it doesn't have a variable on it. Okay, so this 5 is called your constant. So let's use that. We're going to say you would add or possibly subtract, depending on the problem. Add or subtract to cancel out the constant. Okay, so that's step one, is you want to get rid of the constant. Okay, so let's go ahead and do that over here. I want to get rid of the 2 and the 5, but the one that has to go first is that constant, the 5. Now, that minus sign belongs to the 5, so it's kind of like a negative 5. How would you cancel out a negative 5? Well, you would add 5. But whatever I do to one side, I have to do to the other. So I have to add 5 on both sides. And let's see what we're left with. Right here, negative 5 plus 5 cancels to 0. Okay, you don't need to write down 0. Drop down your 2x, and 13 plus 5 is 18. Okay, so that was step one, is we canceled out our constant. Now let's look at step 2. Step 2 would be to get rid of this number 2, right? And what is that called? What is that fancy number called that's attached to your variable? It's called the coefficient. So that coefficient, typically we see it being multiplied, but every once in a while it's going to be divided. Okay, we can still kind of think of it as a coefficient though. So we're going to say multiply slash divide to cancel out the coefficient. Okay. All right, and let's go ahead and do that. So this 2 and x is being multiplied. If x is timesing by 2, I'm going to do the opposite to cancel it out. I'm going to divide by 2. Remember, we use fraction bars now. Whatever I do to one side, I have to do to the other. So I'm going to divide by 2 on both sides. 2 divided by 2 cancels to 1, and 1 times x is just x, which is what I wanted. Wanted to isolate that x, and then 18 divided by 2 is 9. So I get an answer of x equals 9. Okay, now, very important thing to know is, how can I check this? I forced my kids to check all of their test questions last year, and you know what happened? Anybody that did the test passed. Crazy. If you check your work, you'll know whether you get the correct answer or not. So you would know whether to like fix something before you turn it in. Okay, so let's actually write down, so you have it in your notes this one time, how to do a check. It's very simple. All you do is you plug in, or you can say substitute if you want to be fancy. Plug in answer for x, or the variable. Plug in answer for x and see if the equation is balanced. Plug in answer for x and see if the equation is balanced. Okay, so let's go ahead and do that. Let's do our check. Let's check to see if 9 is the correct value of x. So I'm going to plug in my answer for x, because if we're saying that x is 9, well, let's go ahead and replace x with 9 up there. Okay, so I'm going to rewrite this original equation, but I'm going to plug in 9 for x. So I would now have 2 times 9. Notice I use parentheses. I do that a lot when I substitute. I recommend that you do the same. 2 times 9 minus 5 equals 13. So we kind of like to put a little question mark right here because we don't know if it equals that. We're trying to make sure that it does equal that. We want it to equal 13, okay? So the 13 is just going to get dropped down because that side of the equation is already solved. It's already simplified. Okay, so here, I'm going to follow order of operations here because I'm not trying to find out something. I'm just trying to simplify this side. 2 times 9 is 18. And then use a calculator if you have to, but 18 minus 5 is 13. And then I check to see, does 13 actually equal 13? Yeah, it does. If you were to do your check and have something crazy happen and it's like 20 equals 13, you'd go, no, it doesn't. And what that tells you is you did something wrong when you were solving and you need to go back and fix it. Okay, so that's the whole point of doing a check. Okay, so now let's just do some practice. Here's number 1. Negative 3y plus 8 equals 29. Negative 3y plus 8 equals 29. Okay, separate my sides. I go to the side with my variable on it, and I go, oh, I got to get rid of the negative 3 and the 8. Which one do I get rid of first? Get rid of the constant, the one that doesn't have the variable attached. So that 8 has to go first. It has a plus sign in front, so it's positive 8. So I'm going to go ahead and subtract 8 to make it cancel to 0. Whatever I do to one side, I have to do to the other. 8 minus 8 cancels. Yes, you need to show that in your work. And then when you drop this term down, do not forget the negative sign in front. That's a negative 3y. Drop in your equal sign, and then 29 minus 8 is 21. Okay. Now y is not isolated, and it needs to be. So I look and go, how do I get rid of that negative 3? Some of you are thinking, oh, I would add 3. It's an easy mistake to do, but no. When these two numbers are crammed together like that, multiplication is happening, right? So y is multiplying by negative 3. So I'm going to do the inverse of multiplication, which is division. I'm going to divide by negative 3. Whatever I do to one side, I have to do to the other. Negative 3 divided by itself is 1. Drop down the y equals, and then you just have to figure out what positive 21 divided by negative 3 is. It's negative 7. But perhaps I did something wrong, which is possible. So let's go ahead and check our work. I'm going to do it off over here. Hopefully that's okay. Should be able to see it. Okay, so for your check, you take your answer of negative 7 and you plug it in for the variable. So I would have negative 3 times my answer of negative 7 plus 8 supposedly equals 29. Notice how I put the question mark because I'm checking to see if it actually equals 29. So the 29 is just going to get like dropped down. There's nothing we can do on that side. So we're just simplifying the left side. Multiplication has to happen first. Negative times negative is positive, so that's positive 21. You would get your calculator if you needed to. 21 plus 8 is 29. Does 29 equal 29? Yes, it does. So that's just a check. So yeah, we got it correct. Woo. Okay, number 2. 10 minus 5x equals 30. Okay. Separate my two sides. I go to the side with my variable on it. Do I get rid of the 10 or the -5 first? Got to get rid of your constant, the number that doesn't have a variable attached. So the 10 has got to go, okay? Now, does this minus sign belong to the 10 or does it belong to the 5? It belongs to the 5. So we're working with a positive 10. How do you cancel out a positive 10? You subtract 10. So you need to subtract 10 on both sides. 10 minus 10 cancels to nothing. I don't even write 0. What's the point? Drop down my equal sign. 30 minus 10 is 20. Okay. Now I want you to be very careful. Some of you just drop down this 5x right here. That would be a no-no because that 5x is not positive. That negative belongs to it. So you have to make sure that you are dropping down the negative sign with it. Have to. Okay? -5x equals 20. I don't want -5x. I just want x. So I have to undo this multiplication right there by using division. So both sides need to be divided by -5. That way this right here cancels to 1. 1x is just x. Positive 20 divided by -5 is -4. Okay? Let's go ahead and squeeze in a little check here. These become really easier the more you do them, I promise, okay? So I'm gonna take my answer of -4 and I'm gonna plug it in right here. So I'm just gonna rewrite this, 10 minus 5 times my answer of -4, hopefully equals 30. Right side of the equation is already simplified. I just really have to simplify the left side now. So I'm going to drop down to 10, but right here, -5. It's technically a negative, right? -5 times -4 is positive 20. 10 plus 20 is 30. 30 does equal 30. Woo, okay? And you could totally, if this whole area freaks you out, you can totally use a calculator, okay? You're allowed to. Sorry, this is dusty. 10 minus 5 parentheses, -4 parentheses, 30. Boom, okay? You can use a calculator, that's fine. All right, some more practice. Here we go, number 3. And if you're like feeling pretty comfortable at this point, I encourage you to actually like try them out on your own and then listen to my answer, okay? But if you still need some guidance, totally fine. I feel you, okay? X over 3 minus 4 equals -6. X over 3 minus 4 equals -6. Okay, separate my two sides. I go to the side with my variable on it. It's dividing by 3 and then subtracting 4. Remember, we're kind of working backwards. We're sneaking up on to the x. So the last thing it did was subtracted 4, which means that's the first thing we're going to cancel out. So you're going to get rid of your constant, right? So that's a -4 or a -4, right? So either way, I'm going to add 4 in order to cancel that out. Whatever I do to one side, I do to the other. 4's disappear, and I'm left with x over 3 equals something. -6 plus 4 is -2. Okay, are we done? No, x is not by itself. X is currently dividing by 3. How do I cancel it out? Opposite of division is multiplication. So I'm going to multiply by 3 so that that cancels and I'm left with x. But got to keep that equation balanced. Whatever I do to one side, have to do to the other. -2 times +3 is -6. Okay, the check. Some kids seem to struggle with the check. So I'm going to ask that you try it on your own. It'll get better, I promise. Basically, you're just plugging in that -6 wherever x was. okay? So I'm going to rewrite it, but instead of x over 3, I have my answer over 3, negative 6 over 3. Minus 4 hopefully equals negative 6. So the right-hand side of the equation is already simplified. I look on the left, I got to do that division real quick. Negative 6 divided by 3 is negative 2. You could use your calculator, beep, boop, beep. Negative 2 minus 4 is negative 6. The equation is balanced. I'm happy. Okay, sorry, there's a little bit of lag again. We're okay. Okay, number 4, negative 18 equals negative 6 plus 3w. Challenge you to do it on your own. If you need a little help, totally fine. I'm here for you. Okay, I'm going to go to the side with my variable on it. Uh-oh, this time it's on the right. Do we freak out and flip a table over? No, doesn't matter. Okay, we're still going to follow our steps. Remember on the previous page, step 1 is to cancel out the constant. Which one of these is your constant? This dude, okay? It is a negative 6. So how am I going to cancel out a negative 6? I'm going to add 6. Whatever I do to one side, have to do to the other. 6's cancel out to 0. I'm left with a 3w over there. I just have to figure out what negative 18 plus 6 is. Use a calculator, that's fine. Ends up being negative 12. Okay. I'm still not done though, right? I don't want 3w, I just want 1w. So since w is timesing by 3, I'm going to do the inverse of multiplication. I'm going to use division. I'm going to divide both sides by 3. That way, 3 divided by 3 is 1. 1w is just w. Negative 12 divided by positive 3 is negative 4. Now, do I want my final answer to look like this? Nope, I want the variable on the left. Remember, that's the proper way to write our final answer. W equals negative 4. Try out a check. Pause it right here. Don't listen to me. Try it out. Make sure you know how to do a check. Plug in. So negative 18 equals negative 6. Sorry, this is going to squeeze off the page. Plus 3 times negative 4. Sorry, that's crammed. Negative 18 is already simplified over there. We're seeing if this is true. Drop down my negative 6. Positive 3 times negative 4 is negative 12. Take my calculator or my brain. Negative 6 minus 12 is negative 18, so we're good to go. Okay, we're doing 2 more together. All right, I'm kicking it up a little bit, seeing if you remember this from last time. 4/5 x. Yeah, that's a fraction. Fractional coefficient. 4/5 x minus 12 equals negative 4. What to do, what to do? Well, obviously, let's separate our sides, get organized, focus on the side that has your variable on it. And there's still 2 things to get rid of. The 4/5 needs to go and the 12 needs to go. Which one must leave first? Your constant, the one that doesn't have a variable attached, this dude. So that's a negative 12. So I'm going to add 12 to cancel it out. Whatever I do to one side, I do to the other. I'm left with 4/5 x, and then I calculate negative 4 plus 12, which is positive 8. Okay, now the question is, do you remember how to get rid of this fractional coefficient? Look back in your notes if you need to, or look at my hint. Ready? Boop. Remember? You flip it. You flip the 4/5. It's called the reciprocal. If you multiply any fraction by its reciprocal, it'll cancel to 1. Okay? I'll prove it to you. 5 times 4 is 20. 4 times 5 is 20. 20 divided by 20 is 1. Okay, so that cancels. The only thing we got to remember to do is times this side by 5/4 as well. Okay, so multiply share across. 8 times 5 is 40. 1 times 4 is 4. 40 divided by 4 is positive 10. Okay, your check on this one is going to be the same, even if a fraction's involved, the check is the same. I plug in 10 there, so you have 4/5 times 10 minus 12 equals -4. Now, I'm comfortable multiplying fractions. I know that this is going to be 40 over 5, which is 8, but I'll prove it to you on the calculator. I used parentheses to protect the fraction, 4 and then divided by 5 because fraction bar is division. And then I'm going to times it by 10. Let me show you 8. 8 minus 12 is -4. Does -4 equal -4? Sure does. Okay, last one together. I encourage you to try it out without my help. 13 minus y equals -5. Okay, separate the sides. I go to the side of the equation with my variable on it. I thought we were doing two-step equations. I only see one number I need to get rid of. Okay, let's get rid of the 13, right? Am I gonna add or subtract them? Look in front of it. 13 doesn't have a sign, so we know it's positive, right? So therefore, I'm going to subtract 13 on both sides. That cancels out. I'm left with y. -5 minus 13 is -18. Boom, I'm done. Miss Meineke, you're crazy. That was only a one step. Or was it? So maybe you get to this point and you're like, okay, I'll do this stupid little check, even though it's not stupid, it's really smart. 13 minus -18 equals -5. Sorry, that's off the page. I'm going to use my calculator. 13 minus -18, 31. Does 31 equal -5? This is an instant where you would go, whoops, that's not equal. I did something wrong. Can you spot my error that I made? I subtracted 13 because it's positive 13, so that's fine. But you know what? I forgot to bring something down. I forgot to bring this negative sign down. This is not y, it's negative y. And you have to bring it down or else it's going to screw up your answer, right? We just saw that. So we have to remember that this technically has a -1 in front of it then. So how do you get rid of that -1? It's its coefficient. You're not going to add 1, don't you dare. That -1 is timesing by y. So you're going to divide by -1 on both sides. These cancel out. I'm left with positive y, which is what I wanted. -18 divided by -1 is positive 18. Now let's do another check and let's see if that works. 13 minus positive 18 supposedly equals -5. 13 minus 18 is in fact -5. I see that it's balanced. I know I did it correctly. Okay. So I did that on purpose just to kind of show you the point of a check and all that good stuff. Okay. So here are your problems. You're going to have 4 problems to do on your own. 7, 8, 9, and 10. Just to be crystal clear, I expect these to be done and solved before you come to Zoom. That way when I send you the entry task, you just enter in your answers. Okay, here's number 7. X over 2 plus 10 equals 3. Number 8, 5x minus 2 equals negative 22. Number 9, negative 6 minus 3y equals negative 21. Lots of negatives there, be careful. And last one, 2/3 x, woo, fractional coefficient, 2/3 x minus 5 equals 1. Alrighty, thanks for watching, guys. I'll see you in class. Bye.